zeros, then the same matrix is diagonalizable. We have seen echelon form. Every matrix is reducible to echelon form, but every matrix is not reducible to diagonal form. It is not possible to reduce all matrices to diagonal form because the above also should be 0, below also should be zeros, except the diagonal, remaining all should be zeros. So, when is it said to be diagonalizable then? So, first condition is, we have done one question. If criterion is, if all eigenvalues are different, this is called diagonalizability criterion. If all eigenvalues are different, there is a theorem saying that automatically matrix is diagonalizable. If different, that is none of them is repeating, then matrix A is diagonalizable. And what is the diagonal form of the matrix? In that case, diagonalizable. And what is the diagonal form in that case? The diagonal form is given by eigenvalues diagonally, remaining all zeros. So you need not apply elementary operations, directly you can get the diagonal form. If it is diagonalizable, that means all eigenvalues are different, then the diagonal form is given by this. What are lambda 1, lambda 2, lambda n? They are the eigenvalues. Then what is the relation between A and D? The relation between A and D is given by A is equal to PD P inverse. So there exists always a non-singular matrix. If it is diagonalizable, there exists an invertible matrix P satisfying the above condition, matrix P. Then only P inverse exists, given by x1, x2, xn. What are x1, x2, xn? They are nothing but where x1, x2, xn are the eigenvectors corresponding to lambda 1, lambda 2, lambda n. They correspond to these two. That is, x1 corresponds to lambda 1, x2 corresponds to lambda 2, and so on. They are the eigenvectors corresponding to these different eigenvalues. If you, one condition is, you can arrange lambda 1, lambda 2, lambda n in any form. So diagonal form is not unique. If there are n eigenvalues, n places are there. So how many diagonal matrices you can get is n factorial. N eigenvalues, that is, if the order of the matrix is n by n, how many diagonal matrices, how many diagonal forms exist is n factorial. Diagonally n elements, lambda 2 may be in first place, lambda 1 next, like that. You have to arrange n eigenvalues in n different places, diagonal places. It can be done in n factorial. Whatever may be the order, the corresponding eigenvector you have to write in P. Then only this condition will be satisfied. That means if you are writing lambda 1, in P you should write x1. But if you are writing lambda 2 first, then you should write x2 here. So the corresponding eigenvector should match in D and in P. The corresponding eigenvectors you have to write. Whatever eigenvalue you are writing here, same eigenvector, corresponding eigenvector should be present. Then this condition will be satisfied. Okay, fine. Then if it is repeating, can we say it is not diagonalizable, or can we say it is diagonalizable? So if eigenvalues repeats, this is method 2. Method 1 is if all are different, case 1. What is case 2? If suppose some of them are repeating, if some eigenvalues repeats, then if some eigenvalues repeats, then we cannot find out this one directly. We cannot say diagonalizable, we cannot say not diagonalizable. Then what is the criterion? If some eigenvalues are repeated, then corresponding every repeated eigenvalue, corresponding to each repeated eigenvalue, AM must be equal to GM. Corresponding to each and every repeated eigenvalue, AM must be equal to GM. This is, then only A is diagonalizable. That is, A is diagonalizable if and only if it is. It's not only one side condition, it is both sides condition. That is, A is diagonalizable if and only if. In other words, AM is equal to GM for each repeated eigenvalue. Repeated eigenvalue is also called degenerate eigenvalue. For each repeated eigenvalue. So suppose two eigenvalues are repeating. If one of them is satisfying this, another not satisfying, then we say it is not diagonalizable. Corresponding to each repeated eigenvalue, this should be satisfied. What is AM? Where AM is number of times. AM of lambda. It is defined for not for the matrix. Algebraic multiplicity is defined for the eigenvalue. Number of times lambda repeats. This is called AM. What is GM? Dimension of A minus lambda. Corresponding lambda, right? And is given by the formula n minus r. What is n minus r is? N is order of A or number of columns of A. Number of columns of A. R is not rank of A. Rank of A minus lambda. Sometimes you may not be asked to find geometric multiplicity. Instead, you will be asked to find what is the dimension of the matrix. Dimension of the matrix is n minus r. Whatever matrix that is given, for that in that number of columns you have to take and find out rank. How to find rank? Reduce it to echelon form. Not rank of A minus lambda. So how to find out GM is? Let us work out the question. So yesterday we have done one question, 1 1 1 1 diagonalizable. Is 1 1 1. Shall we take okay, 1 1 1 1 1 1 1 1 1 1. Is this matrix diagonalizable? This is the question. How to know whether it is diagonalizable or not? First we have to find out the eigenvalue. So what are the eigenvalues of this matrix? Eigenvalues are
0 0 0 4.
Let us call this as A.
0 0 0
0 0 0 4. How? This is 4 by 4 matrix shortcut. How many zeros should be there? N minus 1. N is 4. So fourth eigenvalue is the order of the matrix. Now they are not different. If they are all different, we would have concluded diagonalizable. But 0 is repeating, 4 is occurring once. If it is not repeating, I told you, you need not check. Because whenever it is occurring only once, algebraic multiplicity will be 1 for 4 and it will be equal to geometric multiplicity. There will be only, that is, geometric multiplicity is also called number of independent eigenvectors. Geometric multiplicity also indicates number of linearly independent eigenvectors corresponding to the eigenvalue. That I'll come to that later. So at present, for whenever it is not repeating, AM equal to GM equal to 1. You need not check. For this, we have to check. So for 0, this is repeated. It is repeated eigenvalue. What is algebraic multiplicity? So it is occurring how many times? 3 times. Now we have to find geometric multiplicity. GM is nothing but equal to dimension of A minus lambda I, which is dimension of A minus 0i, because which eigenvalue is repeating? It is 0. So dimension of A, which is equal to n minus r. N minus r. What is n? N is nothing but number of columns, that is 4. What is r? Rank of A minus lambda I, for lambda equal to 0, which is same as rank of A, because lambda is 0. If lambda is 1, A minus I. A minus I rank we have to find. But here lambda is 0, rank A. So how to find rank of A? We have to reduce it to echelon form. All ones. This is the leader, we have to make below zeros. For R2 apply the operation R2 minus R1. For R3 apply the operation R3 minus R1. For R4 apply the operation R4 minus R1. This reduces to 1, 1, 1, 1. Remaining all zeros. So what is the rank of this matrix is? It is in echelon form. What is the rank is? Number of non-zero rows, which is what? So therefore, what is geometric multiplicity of 0 is n minus r, 4 minus 1, 3. Algebraic multiplicity, how many times it is repeating is 3. Therefore, AM is equal to GM. Therefore, it is diagonalizable. A is diagonalizable. What is the diagonal form then? And diagonal form is given by, you have to arrange eigenvalues diagonally, remaining 4 by 4 matrix, diagonal matrix. This is the diagonal form of the matrix. Okay. Now, how many diagonal forms can you get? This is the end of it. It is diagonalizable or not? Yes. Diagonal form is this. How many? Suppose question is given. How many number of diagonal forms are? Number of diagonal forms corresponding to AR. What is A? All ones. Same, above question. You know it is diagonalizable, but how many diagonal forms exist? Option A, 4 factorial. Option B, 4. Option C, 16. Option D, 9. Can you answer this question?
4 factorial, ma'am.
4 factorial, ma'am. Option A.
Huh?
4, madam.
Correct. Good. Who told 4?
Buddha, madam.
Buddha. Good. Excellent. How did you get 4?
So here 0 eigenvalue is repeated, madam. 4 factorial by 3 factorial ways.
Excellent. Correct. Correct. Excellent. That is the reason I asked for this question. Now you get such tricky questions in the exam. So I told you n eigenvalues, if they are different, this is 4 by 4. How many places are there in the diagonal form? Diagonally 4 places are there. 1, 2, 3, 4. We have to arrange eigenvalues 0, 0, 0, 4. 4 eigenvalues, if they are different, 4 different values, 4 places can be arranged in 4 factorial. But they are not different. If they are different, 4 factorial. But they are not different. Whenever they are repeating, we are arranging 4 values in 4 places. You have done in your intermediate. So if there are 4 objects can be arranged in 4 places in 4 factorial ways by 0 is repeating how many times? 3 times, so 3 factorial. Like how many ways you can arrange the letters of the word mathematics you have done. M repeating how many times, A repeating how many times, like that. So total ways by number of times each letter is repeating. Applying the same concept, 4 values, 4 factorial, 0 is repeating how many times? 3 times. So how many arrangements? Number of arrangements will give you the matrix. So this is 4 into 3 factorial. 3 into 2 into 1, 3 into 2 into 1. 4 is the value. Okay. This is the one. So I will give you one more. For number of diagonal forms, number of possible diagonal forms corresponding to A, matrix A with eigenvalues 2, 2, 3, 3, -6, -6, 7. Tell me how many eigenvalues. What is the order of the matrix? 7. Because 7 eigenvalues are there, 7. Are you doing?
Yes, ma'am.
Yeah, do it. So, which option correct?
C, ma'am.
The option is correct. Not second. Because if you blindly remember, earlier 4 factorial 4, so I said 4. So if you memorize and go, you may write 7, which is not correct. 7 factorial by 2 factorial, 2 factorial, 2 factorial. Why is it so? 7 eigenvalues, 2 is repeating 2 times, 3 is repeating 2 times, -6 repeating 2 times. These dots. Okay, so now you know this. I'll give you one. Number of diagonal forms of a 5 by 5 matrix with eigenvalues 1 plus root 2, 3 minus I, and 1. Number of diagonal forms of a 5 by 5 matrix with eigenvalues 1 plus root 2, 3 minus I, and 1. Can any one of you tell me the answer?
5 factorial by 2 factorial into 2 factorial.
Somebody has given. Everma, Chipindi? Who told this answer?
Matrrix, madam. Okay.
Matrrix. Okay. So he gave one answer. He is very close to the answer.
5
But
factorial
this
ways,
is
madam.
most tempting option. Who told? Buddha?
Yes, madam.
5 factorial. His answer. C, 3 factorial. D, 5p3. Tell me which option correct.
5p3.
Factorial.
Option A, ma'am.
Option A. Someone is saying option A. Someone is saying option D.
Madam, the
Only
1 plus
Buddha.
root 2. 1 plus root 2, one eigenvalue, automatically 1 minus root is also eigenvalue, madam.
Correct.
No,
Good,
madam.
good.
5
So-
factorial.
So which answer is correct is? D
I'm wrong.
option.
5 factorial, madam.
All are different. Okay.
3 minus I. Correct. So this is 1. Whenever I have given one hint, whenever A plus root B is an eigenvalue, a 5 by 5 matrix should have 5 eigenvalues. Only 3 are given. Why only 3 are given? Because we have a concept. Whenever A plus root B is an eigenvalue, its conjugate, what is the conjugate of 1 plus root 2 is? 1 minus root 2 is also an eigenvalue. If 3 minus I is an eigenvalue, its conjugate, how to get conjugate? Replace I by minus I is also an eigenvalue. If 1 is eigenvalue, don't write minus 1 eigenvalue. There is no theorem like that. Only for A plus IB and A plus root B, it is valid. So, 5 eigenvalues. All are different or not? They are all different. So, how many diagonal forms are possible? 5 eigenvalues, 5 places. Why 5 places? 5 by 5 matrix. How many diagonal entries? 5. 5 places, 5 eigenvalues can be arranged in 5 factorial. So, sometimes tricky questions may be given like this. So, this is about diagonalizability. I will give you one more question. Is the matrix diagonalizable? So, how to know whether it is diagonalizable or not? First, we have to get the eigenvalues. So, how to get eigenvalues? First, we have to get the characteristic equation. Determinant A minus lambda equal to 0. That is subtract lambda from this. So, 5, 4, 1, 1 minus lambda 0, 0 lambda. That is 5 minus 4, 5 minus lambda, 4, 1, 1 minus lambda equal to 0. That means 5 minus lambda into 1 minus lambda minus 4 equal to 0. Lambda square minus 6 lambda plus 5 minus 4, 0. Lambda square minus lambda minus 5 lambda, which implies lambda square minus lambda plus 1, 0. So, lambda is equal to minus b plus r minus b square minus 4ac by 2a. 32 by 2. So, what are the eigenvalues? So, the eigenvalues are different. Therefore, diagonalizable. Last question. Is A is equal to 4